All right, everybody, how we doing? So picking back up where we left off with yesterday with our note video for today. Um, so what we did in class a lot of the time today was talking about those electron configurations, right? And if we quickly go back, right, we did all this stuff talking about electron configurations, how to identify them from the periodic table, what the electron configuration tells us about how many electrons there are in an atom, and then lastly, it also tells us the number of valence electrons in that particular atom, right? So electron configuration from the periodic table here, okay, tells us a lot more than what we think it does, right? Surface value, it's just a bunch of numbers with dashes, right? But like usual, okay, knowing how to read the periodic table and kind of translate that into some more information is really, really important. And that's kind of what this electron configuration stuff really does for us. So that was yesterday. And let's focus on what we're going to look at today, which is drawing Bohr models. Okay, so Bohr models are essentially a translation from that electron configuration of, let's say, 2-6 for carbon, right? So carbon has an electron configuration of 2-6. Sorry, 2-4, not 2-6. It has a configuration of 2-4. And I'm going to get my pen out here. Okay, so 2-4, right? That's the configuration of carbon 2-4. So when you write this out, 2-4, and this is something that I did in class today when we talked a lot about electron configuration. Again, the number furthest to the left here, right? This is the left-hand side here. This is left-hand side here. As we go left to right, this is the number of principal energy levels that this particular atom has, right? So this represents our first principal energy level, and this represents our second principal energy level, right? So when we look at this in terms of an actual Bohr model, it's going to translate to talking about actually drawing this Bohr model. So let's take a stab at this, okay? So the example here says draw a Bohr model for an atom of carbon. Okay, we're again talking about carbon here, so we're talking about an atom of carbon in the ground state. And we're going to focus on what ground state means in just a second. But let's just draw this Bohr model here first, okay? Over here, I have the steps to actually draw out a Bohr model. So let's go step by step and make sure we're doing the right thing, okay? So first things first, write out electron configuration. So we're talking about the atom carbon here, okay? So let's make sure we are doing this correctly. First things first, our E, okay, config. Okay, electron configuration for carbon is going to be 2-4. Okay, we know that. We are really familiar with it. We just looked at it on the last slide. Worst case scenario, if you already forgot it, right? Periodic table. Okay, go look at the periodic table. So 2-4. And like I just showed you guys in the previous slide, this set of numbers here, 2-4, means something. It tells us the number of electrons and in that particular energy level, right? So 2 is our first starting number on the farthest left here, right? So 2 is the first principal energy level and the number of electrons in that energy level. And the 4 represents our second PEL. So I'm going to even put the letters PEL in here so we are all on the same page. PEL. Okay, so second PEL has 4 electrons here, right? So now we've established our electron configuration and the number of electrons in each of those principal energy levels. Let's just draw it out, okay? This, of course, is going to be our nucleus, okay? So we don't have to worry about that. We're going to move right on to this first outer shell, right? Our first principal energy level. So all we're doing, guys, is drawing dots directly on these circles here, okay? Kind of like what you saw in the last video when we were doing Bohr models, when I did a very brief example of a Bohr model in the last video, okay? So this is the first principal energy level, and if we remember, we're only drawing 2 electrons, because for every number you see here, this represents the number of electrons on that principal energy level. So we're just drawing 2 in the first. And now that we have the first principal energy level already filled up, because you can only have a max of 2 in the first principal energy level, the second one is where we come into play here with this 4 here, right? So this is where we start to draw out 4. And one thing to note, guys, you might be noticing how much I'm kind of evenly spreading these electrons apart on this particular thing. And actually, what I want to do here is draw a different color, actually, for the valence electrons, right? So let's actually change this up and let's do orange here. Okay, so I'm going to draw over these. Okay. So since these are my valence electrons, right, my outermost electrons, like we talked about in class, okay, those are going to be a different color. This is actually kind of going to be what we do as an activity in class tomorrow. Okay, so showing you all the different electrons in your inner shells, but your outer shell electrons, your valence electrons, are going to be color coded differently here. That's why we got the orange versus the pink here. Okay. So moving on from that, because we're going to spend a lot of time in class tomorrow talking about Bohr models and how to draw them, and actually drawing a bunch of them in class, which will be great. We're going to talk more so now about the excited state, because oftentimes I've been talking about this idea of ground state electrons, ground state atoms, right? Well, what's the opposite of that? Well, the opposite of that is the excited state. The excited state refers to an electron that has gained or absorbed energy and has moved further from the nucleus into a higher energy level. And this is going to require an input of energy to enter that excited state from the ground state. And there's a couple of rules when it comes to identifying electrons and identifying electron configurations in either the ground state or the excited state. So let's take a look at these real quick, and then we're going to end the video with this here. So excited state configuration is going to be just different from the ground state configuration, right? Guys, all of the configurations, okay, on the periodic table, these are all in the ground state right here, okay? So if you're comparing a configuration from the periodic table to what you see on your particular example, and they're not the same, they're different, automatically start thinking, hey, this could be excited state. Number 2, contains the same total number of electrons, right? So if, for example, you've got a ground state electron configuration for carbon of 2-4, that's a total of 6 electrons, right? 2 plus 4 is 6. So if you've got 6 electrons in a configuration of carbon, and you have a different one that looks a little bit different than 2-4, but still has a total of 6 electrons, that is still on the track to being considered excited state. And lastly, number 3, does not have more than 2, 8, 18, and 32 electrons at each of those individual energy levels, right? So the first principal energy level can only have a max of 2, the second can only have a max of 8, third max of 18, and the fourth max of 32. If you go any higher, so 2, higher than 2 being 3, higher than 8 being 9, anything like that, okay, you cannot have any more than what's in those individual principal energy levels, okay? And again, we'll talk more about excited state in class and do some work on excited state in class tomorrow.